1. 2. What if while it is up, the oil transmission line, the line that's feeding oil to the cylinder, should fail? It will collapse and potentially create massive devastation. What we need, and certainly what design engineers consider when they're designing this equipment, is we need a valve that will counter the balance, a counterbalance valve. In other words, here's a transparent cylinder, and imagine we've got this filled with hydraulic oil, and the line breaks at the bottom. It's going to collapse. However, if I put a resistance in the form of a valve in the line directly at the cylinder port, I can prevent that from happening. That's the valve we're going to talk about today. Valve, which right now is closed, which means the oil is trapped inside the cylinder. And as long as the oil is confined, that load will remain stationary. But as we said, if I open the valve and allow the oil to drain out of the cylinder, the load is going to drop, as you can see. When we bring oil in to the bottom of the large piston, it will require 100 psi to open the valve. However, if I bring the oil pressure in to the small piston, it will require 800 psi to open the valve. What have I just done? I've built a pressure relief valve that will open at 2 different pressures. Clearly, what we did was we designed a counterbalance valve, because a counterbalance valve, as you can see here, has 2 pistons. It's got a small piston, and the small piston is going to work with the internal passage, and it's got the larger piston, which works with the remote passage. I've got a pressure relief valve that's going to open at 2 different pressures. Let's study the symbol for the valve. The line dash line will always represent the valve's body. The square or envelope will always represent the moving part inside the valve. If the arrow is offset from the line going through the valve, it's a normally non-passing valve. Let's look at the next problem. That is deceleration. All right. Naturally, if I suddenly stop the load, and we mentioned this, and this is a very good example of it to make the point, that is, if I suddenly stop the load and the pressure spikes, the only way we can mitigate the pressure spike is if we allow the oil to flow. So what do we